Question on the goal.
Oh, yeah.
Isn't tangent cosine on the side?
Tangent is sine over cosine. It's sine over cosine. That is sometimes hard to keep straight. But it's sine over cosine. All right, so any questions on the homework? Sorry, yeah. 77. So we look at 77. All right, the first thing is I can't use this until I pull that 2 out in front. Right? So I need to pull that 2 out in front. That's going to give me cosecant of 2 times x minus something. Something. And the easiest way to get that something is to take that pi over 2. So maybe a little scratch work. Pi over 2 divided by that 2 that I'm pulling out. Alright, so I just take this pi over 2, divide it by the 2 that I'm pulling out. So if distributing is multiplying to put it in, factoring must be dividing it out. So that's going to give me pi over 4. And so that's going to be pi over 4. Do you want me to keep going, or is that where you got stuck? Or do you want me just to keep going further?
I got stuck in a graph.
Okay. So our period, the period is going to be, I didn't ask for it, but you should always figure out what your period is. That's going to be 2 pi over 2, which is pi. So I'm going to count out 4 units, 1, 2, 3, 4. I'm going to put pi there. And then it's going to be pi over 2, because it's half multiplied by 3. 3 pi over 4. All right, cosecant is going to be my sine. So I'm looking at sine, right? I'm looking at sine. I didn't change my amplitude, so nothing's going to get stretched. So in fact, I could expand this a little bit bigger, so it's going to be kind of a tiny graph on there. But that's fine. The only thing I'm doing is I'm shifting it right pi over 4 units, right? Normally, sine starts at 0, 0. But since I'm shifting over 1, this is just so small, I should have thought about this, but that'll be fine. Negative 2. Instead of starting at 0, 0, I'm going to shift it, not pi over 4, it's going to get shifted pi over 2 units. Oh no, it was pi over 4. I was right. It is pi over 4. Shifted pi over 4 units, and then it goes 0, 1, 0, negative 1, 0. I'm going to rewrite those in a lighter shade, just so we can see our final answer a little better. So it goes up, down, down, up. So it looks something like that. That is my sine curve, right? It's just a normal sine curve shifted over pi over 4 units. So then all I have to do is any time that that sine curve reaches 0, I'm just going to put a vertical asymptote. I'm going to put a vertical asymptote. I'm going to put a vertical asymptote. And then let's use purple. This is going to go up. This is going to go up. This is going to go down. And that one's going to go down.
Can I ask one more question?
Yeah.
It's on a different.
Okay.
No. I have a question on 71.
On 71?
Yeah.
I'm going to leave this up for just a sec because I see people writing it down. They might have made mistakes on it. For people writing it down, it's fine. I'm just going to go to 71 and I'll come right back to it because I want to look at 71. All right, 71 is cosecant. Did I go to the wrong one? Oh, you want 73?
Yeah.
Okay. So 73 and 71 are kind of similar problems. All right. I'll come back to this one in case people aren't quite done with this graph. But does everyone, does this make sense? Did I blow anyone's mind with this one? Does that make sense? I saw you changing yours. Okay. I just want to make sure that you saw your mistake and that we correct it. All right, 73, 71. I'm almost asking identical things. I want to see if you can rewrite these Because once I rewrite it, you'll be like, oh, I can do that. So I'm going to rewrite 73, and I always rewrite it as soon as they don't give me the form I like. So I like having a number, and then I want x. I don't want x to be involved in this fraction. So I'm going to rewrite this as secant of pi over 2 times x. Because I can do that because that's the exact same thing as, times x over 1 going backwards. So it's just pi over 2 times x. So that means pi over 2 is what's affecting my period. So if I went down here and I wrote my period is going to be 2 pi over whatever my b value is. My b value is pi over 2 now. Keep, change, flip. I'd keep the top number. I would change the division to multiplication, and I'd flip my bottom fraction to 2 over pi. And remember, that's actually 2 pi over 1. So my pi's cancel out. I'm just left with 2 times 2, which equals 4. And it is okay if your period is 4. You just count 4 units and write 4. And you can still do the half multiplied by 3, but it's just 4, 3, 2, 1. Does that answer enough of that questions on that one? Okay, yeah. I think the hardest part about this one is rewriting this and then realizing that 4 is okay. 4 is okay to have as your period. Okay? Yeah. Yeah. Same thing. What I kind of think about, so x is on top of a fraction, right? X is on top of a fraction here. To get rid of it, it just kind of falls to the side. All right, it can kind of just fall off this and be right next to it. So same thing's going to happen up here. It's just going to kind of fall to the side, and I'm going to rewrite that as cosecant of 1/2 times x. Because 1/2 times x is x over 2. It's just, it makes your life a lot easier to know what your b value is. And once again, it's just 2 pi divided by 1/2. All right, we good on those? Got that warm, fuzzy feeling about them, or are we just angry? They hopefully weren't that bad. Because if you knew how to draw sine curves and cosine curves, you know how to draw the secants and the cosecants. Hopefully. Hopefully you're not overthinking these and you just see cosecant and be like, I can't do it. All right? So no other questions. So you're telling me we got this 100%, that we could take a test right now on it. All right. Then we're going to go ahead and take the test today.
Does that mean no homework?
Yeah, we'll just take a test.
Okay.
No, I'm just kidding. All right, today we actually have to get into tangent and cotangent. Yes?
Like we did in class yesterday, we did a formula for the asymptotes, but you didn't ask for that in the homework. Is
Yeah.
that gonna be on the test?
No. I mean, it's a possibility, but I'm just trying to introduce you to new things like that. If it's on the review, it could possibly be on the test, but otherwise, it won't be on the test. Okay? Yeah, generally if I don't make you practice it in the homework, I'm not going to, because otherwise it's just throwing at you once and you're just going to kind of forget it. Like I said before, we will take a whole unit and just talk about graphs that entire unit. All right, we'll talk about sine, not sine, but domain, range. Today we're going to talk a little bit of domain. Once again, I'm not going to put this on the test, but you should know how to kind of do it. All right, today we're going to talk about tangent and cotangent graphs. These are a whole new beast. So you can kind of think to yourself, everything I know about sine and cosine, let's just go ahead and forget about that. These are two brand new beasts of problems, so don't bring in sine and cosine rules. It is all by its kind of standing by itself. All right, we're going to actually graph them a different way. We're going to do transformations a completely different way. All right, so yours shouldn't have this on here, right? Because this doesn't make sense. I had a conflicting version that saved incorrectly, and I do believe some people took that version home. So I do have to record this just for someone that has it home, that shouldn't be there. All right, to graph tangent, we're just going to pull out some values and some key values. So the first value is tangent of negative pi over 2. Who can give me the tangent value at negative pi over 2, whether you look at a unit circle or you just know it? Yes, it is undefined. Awesome. Well, if negative pi over 2 is undefined, then pi over 2 must also be undefined. Remember, pi over 2 and those are those straight up and downs. In tangents, undefined at straight up and downs. And it's 0 straight across. So our 0 and 180 or our 0 and pi. It's going to be 0. All right. So negative tangent of negative pi over 4. Who can get me that value? And you can look at your unit circle. That's fine. No. Close. I agree with the negative. The 2 seems a bit extreme. It's not even one of our possible tangent values. Yeah? Negative 1. And remember, after tomorrow, you should be able to have those all memorized. Because it's just square root of 3 over 3, 1, and square root of 3. Those are the only 3 new values you have to add to the unit circle. You just got to do it a couple times. All right, the tangent of 0, I already said that was 0. Because anything that's along the x-axis for tangent is 0. And then pi over 4 is going to be 1. Anytime something's is not defined or is undefined on a graph, we do an asymptote. And we're going to do a vertical asymptote wherever tangent is undefined. So that's at negative pi over 2. And pi over 2. Now, if you remember back in Algebra 2, whenever you had vertical asymptotes, there's only a couple things that could happen. It could be a U-shape, it could be a U-shape going down, or it could be an S-shape going either direction. So it's one of those 4 possibilities. That's why I picked points. I picked negative pi over 4 equals negative 1. Well, negative pi over 4 is halfway between 0 and pi over 2, so we're going to make little tick marks here. That's my negative pi over 4. That's my pi over 4. Negative pi over 4 turned out to be negative 1. Tangent of 0 was 0. And tangent of pi over 4 turned out to be 1. And this is how our graph's going to look. It's going to look one of those S shapes. Kind of an S shape. Kind of look more like a snake. So by tomorrow, or Monday if we take a quiz on this, you should be able to just draw this. I don't need this. I just need draw me the tangent of x, and you draw this. You draw an asymptote here, here, draw this squiggly line. You're good. I don't even need this point or this point. I just need the middle point. I need the middle point and this snaky shape. All right, and then you have 100% on that. All right, so tangent, you just got to remember negative pi over 2. Pi over 2, snaky shape. All right, remember that this is just one cycle, so this could repeat. This could repeat. It could go here. And in fact does, but you don't need to draw this. I just want you to realize that this will repeat over and over and over. And it would go all the way over here, all the way over here. All right, so that leads us into our domain. We had range yesterday. Today we're going to add domain into it. Domain is how far left, I'm going the wrong direction for you, but how far left to how far right a graph goes. Well, tangent goes all the way to negative infinity, because it just repeats over and over, and it goes all the way to positive infinity. However, my domain is not negative infinity to infinity, because look at all these points that tangent cannot be. So whenever that happens, we just list the values that x cannot be. All right, if it goes from negative infinity and has a whole bunch of holes in it, we just list all of those holes. So the domain for this one is, I'm basically going to list every time there's a vertical asymptote. So I'm going to say x cannot be anytime I have a vertical asymptote. And what we're going to list for vertical asymptotes is the first thing I'm going to do is I'm going to ask myself, how far apart is each asymptote? And I go from negative pi over 2 to pi over 2, so that must have a length of pi units. It is pi units apart. So x cannot be some multiple of pi, so k times pi, However, we have to change that just a little bit. Because if I do k times pi and I put a 0 in for k, we come up with a vertical asymptote at 0. If I put 1 in for k, that's at pi. And so that's a little bit messed up. What do I need to do?
Minus pi over 2.
Minus pi over 2 or plus pi over 2. Either way, we just need to shift it. I'll use your minus. Minus pi over 2. So k times pi is actually this right here. 0 and pi. And then 2 pi, 3 pi. So I just need to take that and just shift it. And it matches up then. All right? Range, that's easy. It's our lowest point to our highest point. If I put my finger on this graph, how low can I go? I'm just going to keep going forever. I can't get that short. So that's going to be negative infinity. And now I start at negative infinity. I come up. There's no breaks. And I keep getting taller and taller and taller. I can never stop. So it's going to be negative infinity to infinity. And we always use parentheses with infinity. What was our period for sine and cosine? Just a normal sine of x. What was our period? What was that?
2 pi.
2 pi. Did you have 2 pi too?
Yeah.
You got superseded by the guy that didn't raise his hand and just shouted out the answer? No, it's okay. Tangent's a whole new beast. Pi units is all it takes to do one full cycle. All right, so you don't have to draw this next one. You don't have to draw anymore. I just need this guy. So its period is just pi. It's just pi. Our fundamental cycle, I'm not too concerned about fundamental cycle. I told you before when I told you about it, I barely ever talk about it. Our fundamental cycle is negative pi over 2 to pi over 2. It's just asking, basically what are your x values that contain that one cycle that we draw most of the time. All right, that's all it's asking. I'm not going to ask that on a test. That's tangent. Any questions on tangent? I gave you a whole bunch of information, but tomorrow or Monday, all I need you to do is draw these two vertical lines, put a point, go up, put a point, go down, and that's your graph of tangent x. All right? Let's go ahead and do cotangent. We know cotangent is going to have a very similar, once again, you shouldn't have this up here, the secant, so I'm going to erase it off here. You shouldn't have it anyway. They should be similar shaped, because they're just reciprocals. And we'll see how closely they are related. So your biggest struggle with tangent and cotangent is how close they look to each other. All right, and you'll see that. It's going to be hard to keep which one's which. All right, so it's just going to take practice. All right, cotangent of 0. Cotangent of 0. I'm going to go to my unit circle and find tangent of 0. And the tangent of 0, maybe I'll even go to that. My tangent of 0 degrees is 0. So correct me if I'm wrong, but if tangent is 0, that means that cotangent must also be 0. And then I just move on to the next one. Oof.
That is wrong.
Oof. I want our tangent value is 0, correct? I said my tangent is 0. Well, that isn't technically 0. It's actually 0 over 1. Cotangent is the reciprocal. So my cotangent of 0 degrees, or 0, is going to equal 1 over 0. Can I do 1 over 0?
No.
No. It is undefined. Remember this, because I said this is going to be on your test. I said it a couple times yesterday. This will be on your test. I will ask you what is the cotangent of 0 or pi or something, because I want to make sure you fully understand it. It's not to trick you. It's not to be like, oh, tangent 0, so my cotangent must be 0. It is, you need to have that ingrained in your head. If sine is 0, cosecant is undefined. If secant equals 0, then sine, or cosine would be undefined there. It's basically, you can't take the reciprocal of 0. All right, does that, yeah?
On the test, will you,
you will have a resource. Yes, you will. Yep. Okay, so that needs to be undefined. Not 0. That means at pi, my tangent value at pi would also be 0, so my cotangent must also be undefined. All right, can someone give me my cotangent value at pi over 4? Are you okay?
Yes.
Does it make sense, or are you?
Oh yeah.
Oh, okay,
Just
okay.
yawning.
Oh, no, that's fine. I just
Okay.
sometimes when there's side chatter, sometimes it's just because you have no idea what's happening. And you're just like.
Yeah. No. I was just yawning.
Okay, that's fine. Yeah.
Oh, 0.
It's gonna add cotangent of pi over 4.
This is not 0.
It is not 0. That's okay. We'll go to it. Who's got a different idea? What is the cotangent? Aiden.
Okay.
It's going to be 1. And let's look why.
But if the tangent of pi over 4 is 1, oh, then
It's 1 over 1.
also 1.
It's 1 over 1. Yep. So, so we were looking for the cotangent of pi over 4. The tangent of pi over 4 is 1. So the cotangent is the reciprocal of 1, which is still 1. Because it's 1 over 1. You flip it, and you now have a new 1 on top, but it's still 1 over 1. So it should be 1. However, I would agree with if you would have said pi over 2 equals 0. And once more, I'm going to go through this again. Tangent is undefined at pi over 2, but that's because it's 1 over 0. So the reciprocal is going to be 0 over 1, which is defined and will be 0. So if tangent's undefined, cotangent 0. If tangent is 0, cotangent is undefined. That is a big thing you need to know. I can't stress it enough. And then 3 pi over 4 is going to be negative 1. All right, to graph this, we're just going to put a vertical asymptote wherever I've undefined, so that's here. And there's one at pi. So we can already see between tangent and cotangent, tangent starts between negative pi over 2 and goes to pi over 2. Cotangent shifted over. All right. There is going to be a point right in the middle because we can see it's at pi over 2, 0. However, pi over 4 is a positive 1. And 3 pi over 4 is going to be a negative 1. So our shape of our cotangent graph is going to look like this. If tomorrow, Juan, do you have a question?
Yeah. So once you get like 3 points for.
You don't even need 3.
What?
So like tomorrow or Monday?
Yeah.
I don't need 3 points.
No.
Oh.
Not points, but like in that table to the right. Once you get like undefined 1 and 0, can you just assume that the other ones would be like negative 1 or like the negative number and another undefined?
For tangent you can, but you can't always assume that because there's always a chance that this is a U shape and it would come back up. You can almost be certain it's going to either be 1 or negative 1, but you got to check which one it is. Yeah. So I don't want to give that blanket statement that it always works like this. But on the test, or quiz, I'm not giving it, it's not a test. But on the quiz, if I just ask you to graph cotangent of x, you just need to put a vertical asymptote, point, down, down. All right, but look how similar it looks to tangent. Tangent's going up, and we're at the halves. Cotangent goes down, and it's at the 0 and the pi. All right, you got to keep those two things straight. It is almost memorization because you don't want to have to plot these points every single time to figure these out. I just want you to be able to just go boom, boom, cotangent, got it. All right, my domain. My domain is once again all the x values it can't be because it does run from over here to over there. It can't be anything. So our distance is pi. I should do that first. Our distance is pi units. So x can't be k times pi. And I have to check to make sure if I need to shift that at all. So if I plug a 0 in for this, I should have a vertical asymptote at 0. I do. If I plug a 1 in for this, I should have 1 at pi. I do. If I plug a 2 in, there should be 1 at 2 pi. If I wanted to, I could draw 1 at 2 pi because it's just going to repeat those. Our range is going to be the exact same. It's negative infinity to infinity. The period is still pi, just like with cotangent. However, our fundamental cycle starts at 0 and ends at pi. You do not need to do any of this for the quiz if we have one tomorrow or Monday. All right. I say if because I'm not 100% sure, because tomorrow we're doing inverses, which could be a long lesson, so it might be kind of weird to stick it in there, and I got to see what we're doing Monday. But any questions on these two graphs? All right, don't freak out. Don't freak out. That means something different's happening. We need to graph cotangent and tangent, and it's going to be a whole new way to graph. It's harder and it's easier all at once, because we're going to leave a whole bunch of information at the side, and we're going to find a new way to graph these. And why we have to come up with a new way to graph them? Shifting these left and right isn't too bad. It is keeping them equally apart and changing your period all at once that can be completely confusing. All right? So there's a new way, well, not a new way, there's a better way to graph tangent values rather than thinking about shifting left, coming up with my period. So first of all, if you want to come up with your period, instead of 2 pi over b, it's going to be pi over b. That's important to know. In case I ask for the period, you have to know it's pi over b. No longer is it 2 pi over b. That's just with sine, cosine, secant, cosecant. With tangent and cotangent, it is pi over b. So either circle that, I already circled it for you, find some way to remember that it's pi over b. We're just going to do it, and you'll figure out what this means in just a second. We're just going to graph one. I got them up here. All right, this is if I'm tangent, this is if I'm cotangent. So I'm tangent right now. Yours should be correct. I believe, correct me if I'm wrong, but yours should say 2 times tangent of 2 times x plus pi over 2 plus 1. Okay. So I'm using tangent, so I'm going to use this. First of all, I don't care about the amplitude on these graphs. It does change it does squish it and stretch it, but I'm not concerned about that. All right, so I'm not concerned about amplitude unless it's negative, in which case it flips it. So I'm not concerned about amplitude. All right, so we're not doing anything with amplitude. So maybe put a note to yourself that we're not doing anything with amplitude unless it's negative. I do care that it's going to go up 1. I do care about that. It's going to go up 1. And I care about all this stuff, but I'm not going to break it apart. All right? Our goal is to draw 2 vertical asymptotes. Because if I just draw 2 vertical asymptotes, and I know the general shape of a tangent, I'm golden. All right? So our goal is just to draw 2 vertical asymptotes. So I want to picture a tangent. I want to move this one, however far it needs to go, and I want to move this one. That is why we're going to set stuff equal to negative pi over 2 to shift that one, and we'll set stuff equal to pi over 2 to shift that other one. All right, we're just shifting our 2 vertical asymptotes, and then we're just drawing stuff in between it. And in order to do that, all we're going to do is we're just going to take this guy right here, that guy right there, and we're going to go that. I'm going to set that equal to negative pi over 2. And I'm going to set that same thing to pi over 2. Bless you. That's where this came from, and that's what we're doing down there. Now we just have to solve for x.
Why did you say it? Yeah, why did you do that? Like 1 to negative pi over 2 and the other is pi over 2?
Because our goal is to shift this vertical asymptote, which is at negative pi over 2, and this vertical asymptote, which is at pi over 2. So what, in fact, we're doing, I am changing the period and I'm adjusting it left or right of both of my vertical asymptotes. So this one's going to shift the one that's on the left to what I need to, and this is going to shift the one on the right. And let's just go through and see what numbers we come up with and then have questions on that. All right, so first of all, I'm just going to distribute that 2, so we're going to have 2x plus pi equals negative pi over 2. I'm going to subtract pi from both sides, so that's going to be 2x equals negative pi over 2 minus pi, but I'm going to write that as minus 2 pi over 2. That's going to give me 2x equals negative 3 pi over 2. Divide both sides by 2. And we're going to have x equals negative 3 pi over 4. And I apologize if that's a little quick, rushing through the math. You can go back. I just want to get to the important stuff because we only got 5 minutes left, so I'm kind of rushed through the math. This is one of my vertical asymptotes. I'm halfway done graphing this. This is one of my vertical asymptotes. It is shifted and the period is changed. We're going to do the same thing to this one, solve for x. So once again, I'm going to have 2x plus pi equals pi over 2. I'm going to subtract pi from both sides, which would be pi over 2 minus 2 pi over 2 over 2. That's going to give me 2x equals a negative pi over 2. Divide both sides by 2. And we're going to have x equals negative pi over 4. Now all I have to do, and this is as accurate as I want these, is I'm going to plot a vertical asymptote at negative 3 pi over 4, and I'm going to plot one at negative 4. And this is as accurate as I need it to be. Negative 3 pi over 4. Make this one negative pi over 4. Draw some vertical asymptotes through those two things. Smack a point right in the middle. And recall that tangent goes up. So tangent goes up, just like that, and you are done with that graph. So this is a brand new way to graph these. It is so much easier than trying to shift stuff left and right and change periods because it becomes very, very confusing otherwise. This is as easy as it gets, but now we just have to go up 1. That's the only addition we have to add to this, is going up 1. So go up 1. I should have my y-axis marked. I just don't have time because I want to get to the next one. But that is my up 1. So all I did is this adjusts the period and your shift to both of your vertical asymptotes. And as long as you know what tangent looks like, you're done. All right, you just draw those two lines, and you shift up and down. All right, I'm going to get to the next one. Sorry, it'll be posted on the video too if you didn't quite get all that. All right, this one's cotangent. Well, cotangent has a vertical asymptote at 0 and pi. This is why our cotangent has them set up equal to 0 and pi instead of negative pi over 2 and pi over 2. All right, but we're going to do the same exact stuff. Once again, unless this is negative, I don't care about our amplitude. All right, I'm not going to care about our amplitude unless it's equal to 0. So I'm going to take this And I'm going to set it equal to my left-hand bound of my normal cotangent, which is 0. And I'm going to go 3 times x minus pi is equal to my right-hand bound of my first set of vertical asymptotes, which is going to be pi. I'm going to kind of rush through this. So I have 3x minus 3 pi. Add 3 pi to both sides. We have 3x equals 3 pi. Divide both sides by 3 and have x equals pi. On the other one, I'm going to have 3x minus 3 pi equals pi. Subtract 3 pi from both sides. We're going to have 3x equals negative 2 pi. Or, I'm sorry, a positive 4 pi. Divide both sides by 3 and we have x equals 4 pi over 3. That is the hardest part you should have to do. Alright, because we're not shifting up or down. We're not worried about the amplitude unless it's negative. So now I'm just going to pick a point over here and call it pi. 3 pi over 4 is bigger than pi. Really quickly, I'm just going to put 1, 2, just so I have these labeled. I'm going to put vertical asymptotes at those two places. I'm going to put a point smack dab in the middle. And cotangent goes down, so it's going to look something like this. Oh, I'm sorry, it's 4 pi over. It was me kind of rushing through. It was 4 pi over 3. That was me trying to get you out of there. But yeah, it was 4 pi over 3 because of the 4 pi over 3. So with tangent and cotangent, just set them equal to these, get your two vertical asymptotes, and then just worry about shifting up or down. All right. Finish your homework.